Hello, I'm Daniel and today we will now be doing A-level mathematics. Today we will now do the topic on differentiation. The textbook I am using is by Linsky, Nicholson and Weston and is made by the Oxford University Press. Let's talk about the gradient of the tangent. Let's use y equals to x squared. But the problem is, how are we going to estimate or calculate the gradient at x equals to 2? It's very difficult, especially when you only have algebra. Let's talk about this. So let the curve be y equals to f of x and h be arbitrarily small. It doesn't matter which curve f of x is. So the gradient just turns out to be a limit. Fx plus h minus fx over h. This is called the secant. This is called the secant line. And if you take the limit of the secant, it becomes the tangent when h equals to 0. And this is called differentiation and is used to calculate gradients. Differentiation has several notations, and they are all summarized in this slide. Feel free to memorize them if you wish. Here's a disclaimer. The derivations for this video are taken from this awesome book by Jason Wilkes. It's called Burn Math Class. It teaches you how to actually derive calculus formulae. So let's talk about differentiation on polynomials first. F of x equals x to the power of n. So x plus h power n minus xn over h. And then we do the binomial expansion, and then we divide and subtract, then we get this, and then divide, and h is equals 0, the limit tends toward nx to the power of n minus 1. And then we have just differentiated x to the power of n. How about differentiation on a sum? Use the limit with these. Now, look at this, and then it splits nicely into two derivatives. That's the sum of the derivatives. Ain't it nice? How about a scalar multiplication? A times 3 to the power of x. A times 3x. Then we do the same procedures and it's realized it's a times the derivative. This is what's known as a linear function, which means that when you do scalar multiplication and addition and subtraction of these functions, this means that you still have the linear and scalar multiplications as normal. So with these tools in mind, we can calculate all polynomials derivatives with one exception. D over dxn equals to 0. Because if you draw the graph of n, it's just a straight horizontal line and it has no gradient. Then, example, here's it. And then use the rules. So then you find d over dx, then you just follow the rules and you're good to go. 20x cubed plus 2x. Now there's one last rule I would like to talk about in this video, chain rule. Let dy over dx is this. Now we'll do a genius move right here. We are going to use g of x. dy over dgx is fgx. So dgx over dx is g prime x. So basically dy over dx equals to dy over dgx times dgx over dx. And then we get g prime x f prime gx. Example. Whoa, now this is deep. How are we gonna solve this? Use the chain rule. D over dx equals to 100 times the thing in the brackets power 99 times the derivative, because if you go recall the chain rule, it's exactly this way. And at x to the power 3/2, you still have the same rule. So how about the equations of tangent and normal? This time it's a flashback to our coordinate geometry days. So y minus y1 is mx minus x1. That's the equation. So simplify to y equals to mx plus c you need to. But for now, let's say that the gradient of the normal is negative 1 over m. Because the normal is actually perpendicular to the tangent, which has gradient m. Okay, so this book called Burn Math Class helps you to understand differentiation and integration, trigonometry, Taylor series, and differential equations, which are also covered in A-level further mathematics. And today I say, see you, copper!